In this question, when a light of frequency 2 nu naught, where nu naught is the threshold frequency, is incident on a metal plate, the maximum velocity of the electrons emitted is V1. When the frequency is increased to 5 nu naught, the maximum velocity of the electrons emitted is V2. The ratio of V1 is to V2 is. Now, to solve this problem, we have to use Einstein's photoelectric equation. Now, according to the equation, half mv max square, that is the maximum kinetic energy of the emitted photoelectrons, is equal to h nu minus h nu naught, where h nu is the energy of the incident radiation and nu is the frequency of the incident radiation, and h nu naught is the work function of the metal, and nu naught is the threshold frequency. Now K max, as I mentioned earlier, is nothing but the maximum kinetic energy of the emitted free electrons. Now, according to the first condition, when the incident frequency is 2 nu naught, the velocity of the emitted electron is V1. So I can write half m V1 square as h into 2 nu naught minus h nu naught, that is h nu naught. Let's name this equation as equation 1, and according to the problem, when the frequency of the incident radiation is increased to 5 nu naught, the velocity of the photoelectrons emitted becomes V2. So half m V2 square equals to h into 5 nu naught minus h nu naught, that is 4h nu naught. Let's name this equation as equation 2. See, here W naught, that is the work function, is same in both equations, that is h nu naught, because the light is incident on the same metal plate. Now, dividing the equations, we will get V1 square by V2 square as h nu naught divided by 4h nu naught, that is 1 by 4. Therefore, V1 is to V2 equals to 1 is to 2. So option 1 is correct. That is our answer. Thank you for watching this video. Please subscribe to my channel Phi Solver.